Hello, 5th grade distance learners, and welcome to week 37 of distance learning. We're going to be talking about Spiral Review 6.5 all the way to 10.1 today. As you notice, it's not really in numerical order anymore. And the feedback I'm getting still is you like this one big, long math video, so that's what we're going to do today. Get a comfortable seat, grab your pencil and notebook, and let's begin. First thing we're going to be reviewing is telling the difference between time. So let's say that you leave your house at 4:15 p.m. and you get to where you're going at 6:25 p.m. The question is, how long have you been traveling? So here's what I do. First, I count the difference between the hours. 4 to 5 is 1 hour, 5 to 6 is 2 hours, okay? 2 hours, which we represent with HRS. Now I count the difference between minutes. 15 minutes to 25 minutes. Well, what's the difference between 15 and 25? 10 minutes, which we represent with MINS. So if you left your house at 4:15, got to where you're going at 6:25, you were driving for 2 hours and 10 minutes. Now there is something you need to be careful though, which we figured out with the in-person students. And that's that, well, what if I have, going from 2:35 p.m. and I get to where I'm going at 5:10 p.m. Okay, well, if I do that, I can't just count the difference between the hours here, because the minute 35 is after 10 minutes, okay? So what I'm going to do on this one is I'm going to count up from 2:35. So start with me. 2:35 to 3:35 is 1 hour. 3:35 to 4:35 is 2 hours. 4:35 to 5:35, nope, can't do that because it's 5:10. So I know that it's 2 hours, okay? Well, how many minutes? 4:35 to 5:10. Let's count up in 5-minute intervals. 4:40, 4:45, 4:50, 4:55, 5 o'clock, 5:05, 5:10. That's 7. Well, what's 5 times 7? 5 times 7 is 35. So this one's actually 2 hours and 35 minutes, a little bit longer than what you're traveling before. The next thing we're going to be learning today is absolute value, okay? When I'm thinking about a relationship of numbers, and I've got something that looks like this. This is a number line. The middle is 0. Going up, I go positive 1, 2, 3. Going down, I call it negative 1, negative 2, negative 3. It's kind of hard for us to imagine because here in Arizona we don't get negative degrees, but 0 degrees, and if you crank your freezer to super cold, it's going to drop below 0. 1 degree below 0, 2 degrees below 0. Where I used to live in Minnesota, we would drop below 0 all the time in the winter time because it gets so cold. So let's talk about something called absolute value, okay? Let's take negative 1. The absolute value of negative 1 is how much space is between it and 0? Well, just one space. So the absolute value is 1. How about positive 3? Positive 3. Right up here. How many spaces between it and 0? 1, 2, 3. So the absolute value is 3. What about negative 3? Negative 3. How many spaces between it and 0? 1, 2, 3. So the absolute value is 3. Okay? And something about positives and negatives when you're adding. Well, positive 7 plus positive 8. Two positive numbers. That's what you've been used to been adding together since you were in first grade. 7 plus 8 is 15. Okay, that's not bad. What if I have positive 3 plus negative 2? Well, the negative drops me down. You see how negative gets the numbers, it's kind of like backwards counting. 1, 2, 3 going down instead of 1, 2, 3 going up. So you can think about it this way. Positive 3, negative 2. I like to think about debt. So if I give you $3, but then I borrow $2 from you, how much money did you actually give from me? If I gave you $3, but then I borrowed $2, 1. You still have one more dollar. Okay? With negatives, it's even trickier, because what if I have negative 4 plus negative 6? Again, think about negative numbers as negative, like you're borrowing money. So I borrow $4 from you, and then I come back to you the next day and borrow 6 more. How much money do I owe you now? 10. So we call it negative 10. Negative 4 plus negative 6 gets me negative 10. Okay? So that's how we work out. Let's do one more example so you get the hang of it. What about positive 40? Let's talk about temperature now. Okay? It's 40 degrees above 0. But then it gets colder. 10 degrees below 0. 40 plus negative 10, you can think of it like 40 subtract 10. You get 30. Positive 30. Okay? So positive and negatives, you can think about it as money, or you can think about it as temperature. Both are correct in whatever way helps you more. All right, the next thing we're going to be talking about is double bar graphs. Okay? Here's a double bar graph on your sheet. Now a double bar graph, if you look carefully, tells me on one side the temperature going up from 0 and the day of the week. Tells me the average high temperature and the average low temperature. So looking at this, what was the highest temperature on this graph? 10. What day did that happen? Monday. What was the coldest temperature on this graph? Well, this bar is the shortest, but it's in between 0 and 2. What number is between 0 and 2? 1. Good. 1 is between 0 and 2. What day was that? Wednesday. All right. What day had, or what 2 days of the week had the same low temperature? Monday and Tuesday. Monday was 6, Tuesday was 6 for the gray, the low temperature. What 2 days of the week shared the same high temperature? Tuesday and Friday. Tuesday was up to 8, Friday was up to 8. All right. Now the next thing we're going to be talking about is prime or composite. A prime number is a number that cannot be divided by anything except for itself, and 1. A composite number is a number that can be divided. So for example, let's think up our numbers. Skipping the number 1, the number 2. Can the number 2 be divided? Only by 2 and 1, so that's a prime. Can the number 3 be divided? Only by 3 and 1, so it's a prime number. Can 4 be divided? Yes, 4 can be divided by 2. 4 divided by 2 is 2, so 4 is composite. Can 5 be divided? No, 5 is prime. Can 6 be divided? Yes, 6 divided by 2 is 3, or 6 divided by 3 is 2. So 6 is a composite. And we can keep going forever. We'll do a few more so you get the hang of it. Can 7 be divided? No, 7 is prime. Can 8 be divided? Yes, 8 divided by 2 is 4. 8 divided by 4 is 2. 8 is composite. Can 9 be divided? Yes, 9 divided by 3 is 3. 9 is composite. Can 10 be divided? Yes, 10 divided by 2 is 5. 10 divided by 5 is 2. 10 is composite. Can 11 be divided? No, 11 cannot be divided. 11 is prime. Can 12 be divided? Yes, 12 divided by 2 is 6. 12 divided by 6 is 2. 12 is composite. Can 13 be divided? No, 13 cannot be divided. 13 is prime. So, like I said, 5th grade, we can keep going forever, but what I want you to understand is that prime numbers cannot be divided, composite numbers can, and it's a good idea to just have these prime numbers memorized. 2, 3, 5, 7, 11, 13. Okay? Doesn't mean that numbers that end in 2 are prime, because 12 is a composite number. Doesn't mean that numbers that end in 3 are necessarily either. But if you're just thinking through in your head, can I divide this number by anything? No, it's a prime. Yes, it's a composite. Now we're going to review something we talked about way back in the winter, which is GCF. GCF stands for greatest common factor. Okay? So if I have the numbers 12 and 14, what I'm going to ask myself is the greatest common factor. What numbers multiplied together give me 12? What numbers multiplied together give me 14? Let's rewrite them so they're like this. All right. Think. What numbers multiplied together give me 12? Oh, 12 times 1. Okay. 2 times 6. Good. Anything else? 3 times 4. Good. Those are all the factors of 12. 1, 2, 3, 4, 6, 12. Now let's do 14. 1 times 14. Good. 2 times 7. Good. 3? No. 4? No. 5? No. So these are all the factors. 1, 2, 7, 14. Which one is the greatest that they have in common? 1, 2, that's it. That makes 2 the greatest common factor. Well, let's stick with that same numbers, 12 and 14. But now let's review another idea we talked about way back in the winter, which is LCM, least common multiple. Okay? So what I'm going to do is I'm going to start multiplying out my multiplication charts using 12. 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. Let's stop there. Let's start doing the multiples of 14. 14 times 2 is 28. 14 times 3 is, it's not going to be 30, it's going to be 42. Do I have any number in common yet? No, I don't, so let's keep going. 12, 24, 36, 48, 60. 60, 72. All right, I ran out of space. Let's go down here. 14, 28, 42, 56, 70. Do I have any common multiples? No, no common multiples. So if there's no common multiples between this row or this row, I would just say no common multiples. All right. Now what we're going to do is we're going to check divisibility rules, okay? So let's take a number, 16. And I'm going to ask, can you do 16 divided by 2? Can you do 16 divided by 3? How about by 4? How about by 5? Okay, so let's see if we can solve it out. 16 divided by 2 is 8. Very good. 16 divided by 3. Start counting threes with me. 3, 6, 9, 12, 15, 18. Uh-oh. Barp, barp. No 16. 16 cannot be divided by 3 equally. Let's try 4s. Count up with me by 4s. 4, 8, 12, 16. Bump, bump. It is. 16 divided by 4 is 4. How about 5? Let's try 16 divided by 5. Count up by 5s. 5, 10, 15, 20. Uh-oh. I'm over 16 and I didn't say it. So it cannot be divided by 5. So according to our divisibility rules, 16 can be divided by 2 and 4, but it cannot be divided by 3 and 5. All right. Let's try that one more time so I can make sure you get the hang of it. Let's try a different number this time. Let's try 65. Okay, 65 divided by 2. Let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Do I have to keep counting up like that? You could, or you can just ask yourself, 5. Can 5 be divided by 2? No, 5 doesn't have to be divided, or 5 can't be divided by 2. Doesn't fit. All right, how about 3? Can 3 fit in there? Well, if you're unsure, do a little long division. 65 in the box, 3 outside. 3 fits in the 6 twice. 2 times 3 is 6. 6 subtract 6 is 0. Drop down the 5. 3 can only fit into 5 once. 1 times 3 is 3. 5 subtract 3 is 2. So you get 21 remainder 2. Because of that remainder, I'm going to say I can't divide it equally. Can't divide it equally. Well, now let's do the same for 4. Let's see if 4 can fit inside there equally. Okay, let's put 4 over here. 4 fits into 6 one time. 1 times 4 is 4. 6 subtract 4 is 2. Bring down the 5. Can 4 fit in the 25 equally? 6 times, but 6 times 4 is 24, which means I have a remainder of 1. 16 remainder 1 tells me 4 can't fit in there equally. Doesn't work. Let's try our last number. Let's try 5. Six divided by 5 is 1. 1 times 5 is 5. Subtract it out, you get 1. Drop down to 5. 5 fits in the 15 3 times. 3 times 5 is 15. Nothing left. It does fit in there. It fits in there 13 times. So according to our divisibility rule, 65 is only divisible by 5, not by 2, 3, or 4. Well, why do I need to do divisibility rules? Well, it's important to know what numbers can be divided by what numbers when we are simplifying fractions. For example, I'm not going to pull out my fraction bar today because we're going to focus on the numbers. 6 and 8. Is there a number that can fit inside of 6 and 8? Yes. 2 can. Okay, so let's divide the top by 2, divide the bottom by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. I get 3/4. So what that means is this. If you cut your pizza into 8 slices and you eat 6 of them, it's the exact same thing as cutting your pizza into 4 slices and eating 3 of them. You might be tempted to think, but I only ate 3 of them. Well, yeah, but each piece was bigger. 3/4 is equal to 6/8. Let's do that again. What if I have 18 over 42? Is there a number that can fit inside of 18 and inside of 42? Let's try 6. 18 divided by 6, 42 divided by 6. 18 divided by 6 is 3. 42 divided by 6 is 7. So if you get a pizza and you cut it into 42 teeny tiny slices and you ate 18 of them, it's the same thing as if you would have cut that pizza into 7 pieces and only had 3 of them. Because 18 over 42 equals 3 over 7. Okay? All right. One last thing we're going to review today, and that is comparisons. Okay? If I have 1 and 1/10 compared to 1 and 11/100ths, greater than, less than, or equal to? Think of it like this. What if I put a 0 here? And you read it like money. $1.10 versus $1.11. Ah, now I can see. 1 and 1/10 is less than 1 and 11/100ths. Okay? Now let's think back, still thinking back to comparison, to talking about negative numbers. -3 compared to +2. When do you have more money? When you owe somebody $3 or when you have $2 in your pocket? When you have $2 in your pocket. So we would say -3 is less than +2. Okay? Well, but what if both numbers were negative? You owe somebody $3 or you owe somebody $2. Which one do you owe somebody less money? We'd still say -2 is greater, because it's greater to owe somebody less money than to owe somebody more money. Even though 3 is a bigger number than 2, owing somebody $3 means you have even less money than if you only owed somebody $2. So we'd say -3 is less than -2. Okay? All right. Please bring all your math questions to our Zoom calls Tuesday and Thursday at 2 o'clock. God bless.